Those who are in Zoom, you can see that screen, right? On your computer, like this PowerPoint. Okay, good. So let's start working on class example 9. Your class was a little bit ahead of the other section, so we already did something. But since it was 2 days ago, I will go through very quickly what we did, and then we will start working on that. So basically, we were trying to find what would be the force of water on the Hoover Dam wall, right? So that's what we were trying to find. And we know the area of the Hoover Dam wall, we know the height and everything, we know the angle, like how much inclined the wall is. Oh, one correction here. I said that inclined vertical wall, that doesn't make any sense because vertical is that, inclined is that. So that should be inclined plain wall or inclined straight wall, something like that, just to mean that it is not curved. It is just a straight line or something like that. Okay. So we did that, and we also found out, okay, what will be the relation between vertical distance and the inclined distance, which is h equals to y sine 70, because that was the angle we found. Then we also drew what will be the pressure distribution on wall, because we need that for force calculation, right? Because force equals to pressure times area. That's what we did. Now our next step is, once we know the pressure distribution, we need to find what will be the resultant force due to that pressure. So that's where we stopped. We need to calculate the H bar, we need to calculate the area. We only know the gamma. That's where we stop. Now we will start from this point. Now the question is, how can we calculate the area of the trapezoidal surface? If you can remember the equation, that is absolutely wonderful. If you can't remember the equation, what you can do, you have one package just like that from your AP manual. Since we are working with the trapezoidal cross section, we will use this line. Okay. Here you can find the area. Maybe from board you can't see the font properly, but you have that package with you, right? You can get the area from there. So the area is this one, H A plus B over 2. Now the question is, what is A and what is B? So A and B are the length of the parallel arms of the trapezoidal. So A is the smaller one or B is the smaller one? And the B is the larger one, right? Okay, you need to make sure that one, otherwise you may get the wrong result. So let's start working on this part. So A is the, we said that A is the smaller one, and 1244 is actually B, and 576 is actually H. And we also wrote that here as well. Now, can you calculate the area very quickly? 576, 1244 plus 660 over 2.
548,362.
Okay. I need to write down 54. What else? 83 and 52. Okay. And the unit will be? Okay. So area is done. You can calculate that. Now the next part is, how can we calculate H prime, right? So H prime, at first we need to calculate the Y prime, or not prime actually, Y bar, because the equation you have here, you see this YC and Y bar, that is the Y bar actually. So we have the equation for Y bar, like along the plane, but we need to use H bar. So we need to do something. That's what we will do here. So what I will do, I will go to the next slide because I will need more space, and I will draw these things again. you can keep what you have in your copy. Okay, so that was the case. This one was A, B, C, and we had the pressure distribution, something like that. Equals to 0, equals to 576 gamma, and we had a resultant force here, Fr, right? Now I need to find out what is, that is Yp. Right now I'm not finding Yp because I don't need that Yp right now. Rather, I will find what is the centroid of this trapezoidal area, Y bar. Okay, and the corresponding vertical height will be Y bar, right? And what is the relation between Y and H? We established in our last class. What is that? They are not equal, yes. So H equals to Y times sine 70. For prime, it will be prime also. Okay. So what we will do, we will calculate the Y bar first from that equation. H times 2A plus B over 3 times A and B, A plus B. So let's write down that. Here, H is 576, we know that. 2 times 660 plus 1244. 3 times 6. 1244. So give me that number. And then we will find H prime.
$258.55.
258.55, we can say 259, right? Because if you look at the depth, if you look at the area, it's so huge that 1 to 2 feet doesn't matter that much. Feet from where? That would be the correct answer, the water surface, because top can be top of the wall, from where we are not calculating. Okay, so 259 sine 70 degree. So what will be that number? To 259 sine 70 is what? Something around 243. Okay. 243.5, 0.4. Okay. Again, feet. Okay. Now we have H prime, and we can calculate the resultant force now. Can you calculate the resultant force very quickly? Now you have everything, which is Fr equals to gamma times H prime times A. Gamma is 62.4. H is 243.4. And area is what? A huge number, which is 5,483.52. So this one is Newton over meter cube. Oh, no, that is not Newton over meter cube. What will be the correct unit for 62.4? What will be the unit for 62.4? Pounds over feet cube. This one is feet. This one is feet. This one is feet square. So feet cube will get cancelled. Finally, you will have only pounds. So give me the number in terms of 10 to the power something. Give me the answer for FI. You have that.
Eight 8.3 times 10 to the 9.
Anyone else got something like that? Oops. Anyone else? I got 2 people who got kind of same number. Okay, 3. Good. And it is confirmed that I also got 8.21 into the 9. So this is the force, and you can see huge amount of force. Yes. Now, when they designed that, that's how like they designed that. Okay, we have to design a plate which can withstand that amount of pressure. That's how they designed all the reinforcement, what will the width and everything. That's how they did that. Now, for designing, are you doing beam design and everything? Have you started working on that? Beam design, column design. Okay, you will do that at some point. Basically, everything is you need to, okay, you did the bending moment diagram, shear force diagram for your static, right? That's because when you design a structure, you have to resist the bending moment. Like due to load, obviously it will be bended, so you have to resist that. So for moment, with force, you need what? Distance. Otherwise, you can't calculate the moment, right? So once we know the force, what is the next step? We need to calculate this location, YP, right? So that's what we will do. Let's do that. Location of FR. So it's YP equals to Y bar, IX bar, Y bar, A. Okay. So just to show you what is YP, you can see here from this water surface, YP is the distance up to this point. So we are trying to calculate YP first, and then we will do the other stuff. Now we know the Y bar, right?
Yeah.
What is that Y bar? 254, okay. Yes, R, and this one is the YP, okay. And I will also find the distance here. This is the water surface. This is 576. This one is 7.6 feet. Okay. Now, what was the Y bar? 259. Okay. Plus 9. The area was 548352. Okay. Now we need to calculate the IX. Again, you will go to that one, and you can use this one here. So that should be the IX. Equation is what? H cube A square plus 4AB plus B square 6 A plus B. Okay, so get that number and then we will work on that. Okay. So for Ix, I got something 1.41 10 to the power 10. Let's check your calculation if you got something similar to that. What number you got for Ix? No one got any answer yet? 14.2. I think it should be 10 to the power 9 or something.
Which height?
576.
Why?
You tell me why. That's because, no, that is a good question because we will discuss that in next part. We are not doing anything from the top of the wall because when there is no water, no hydrostatic force. So if you draw a pressure profile from that point, that will be a wrong because no water, no hydrostatic force. So we have to always start from the water surface. Yes, sir. Actually, 36. Did I? Okay. That is actually 36. Now give me the answer. 10 to the power 10, right? Now it seems correct. 1.47 10 to the power 10 feet to the power 4, right? Okay, use that here. 1.47 10 to the power. Oh, that should be not 7 10 to the power. What is that? 9 or 10? 10, I guess, right?
10.
Yes. Okay. Now give me the answer for YP. You should get something around 364, something like that, 365.
62.
Okay, 362. Now this 362 feet from where? That AB, that is BE or AF?
Hmm.
BE, yes. Okay. Now the question, they are asking you to find these YP from top of the wall also. How can you work on that? YP from AF. How can you work on that? I will just add this distance, right? So this distance is what? 762 minus 576. That is a vertical distance. We are working with inclined distance here. So we need to, what is the relation between H and Y? H equals to Y sine theta. So divide by Sine 70. I will go to the next page just to explain that again, but are you done up to this point? So what we will do here, YP equals to 362 from PE, which is water surface, that was the water surface, BE, AF, and the distance for this one 576, and distance for this one is 726 feet. Now this plate is obviously inclined, so if I see the side view, this distance is 576 and this distance is what? 726, right? So now I know the YP, which is 362 feet from BE. Now I need to know what? This one. How can I find that? If I just add this distance, right? So AB equals to what? 726, 5. 76. Sine 770, that's because H equals to Y sine 70. That means Y equals to H over sine 70. Right? Now, what answer you got? 150 over sine 70 equals to 159. Okay. Feet. So YP is 362 plus 159.6 from which surface? AF, right? What will be the final answer here? Five 20, something like that. Yeah. Now, please make a note here. No water, no hydrostatic force, and that's why we are not doing anything for these surfaces. Okay? No water or any liquid.
Yeah.
No hydrostatic. The reason I'm saying this, if I ask you this question for test or for your homework, and I ask a tricky question, instead of saying calculate the YP, I can say what will be the distance of the, or what will be the location of the force from AF. So you need to do the same calculation, but some of you, what you will do, you will start to do all the calculation from AF. You will draw the pressure profile from that point, you will do all the calculation. That will be a wastage of time because there is no water in between A and B. So there will be no hydrostatic force. Okay. So that can be a tricky question. Keep that in mind for your test. Okay. Are we good up to this point? What we are doing? So for inclined surface, we know H and Y, they are not same. They have a relation between H and Y based on the angle. And that's why we always have to make that adjustment, whether we're calculating Y or H. Like we need to calculate the other one considering the angle, right? That was the only difference here. Now, are we good up to this point? Everyone, you can try to calculate the force and the location, right? The main thing is for force magnitude, you need to know the vertical distance, and for location, you need to know the distance along the plate, right? If you're good, then start working on the next class example, which is 9B. Okay? 9B, again, a little bit different from 9A. Here we have two types of surfaces. Now, before discussing that part, can anyone read the question? 9B, loudly and enough quickly so that everyone can understand. Who will read the question? 9B. Not you. You read that, yes, in last class. Someone else. You did that. You did that. Okay. Thank you very much. So here we are seeing the side view here, and this is one vertical wall. This is one vertical, the horizontal wall here, okay? And in between these two walls, we have a gate, which is inclined in 45-degree angle with the horizontal one. And there is a hinge here. Have you ever seen something, some valve, like it will open on one direction only, not on the both direction? Or just think about this door. Can you open that door the outside direction? You can't. It will only open in this direction, right? This gate is something like that. It will only open in the direction where the water is. It will not open on the other direction because there is a huge amount of water pressure on this gate, which will make this door gate closed. So they are asking you to find what will be the force P to open that gate. In other words, what will be the force you need to resist the water force so that you can open the gate. Okay, so that's what we need to calculate. I chose this example carefully because here we will see if we have a vertical plate and an inclined plate, how can we do the calculation? Okay, so that's what we will do. As our very first step, again, we will do the pressure distribution and then we will calculate the pressure. If we have time, we will calculate the location also. If not, that's absolutely fine. Okay. So I will draw again this one. This is the vertical gate. This is the not gate, the plate actually. And this is the gate. Okay. Now you know the distance of this one, which is 12 what? Meter or feet. Okay. And I don't know what is the distance here, but we can find out that. What I will do, I will draw this gate separately here. Okay, so this one is H, this one is Y, and the angle between them is 45. So what will be the relation between H and Y? Sine 45 H over Y. So H is Y sine 45. Okay. Now this gate, do we know the dimension of the gate? What is the dimension of the gate? 6 by 6 square gate, right? So this one is, sorry, 60 centimeter. That means 0.6 meter and 0.6 meter on the other side, right? That means if this one is 0.6 meter, what will be that? 0.6 times sine 45, right? What is that number? Say it loudly, 0.42 meter, right? Okay, we know that part. And that means pressure at this point is what? Pressure at top. What is the 0? What is the pressure magnitude here? The depth is 12, so 12 gamma. Here, 12 plus 424 gamma, right? Is that correct magnitude of pressure on each point? Okay. And we know the distribution will be triangular here. So what we will do now, what is the direction of force to be considered as pressure? Like the force should be perpendicular to the surface, right? So what I will do, I will divide that into two parts just to show the proper pressure distribution here. I'm just separating two to show the pressure distribution properly. So here, P equals to 0, P equals to 12 gamma. Again here, P equals to 12 gamma, 12.424 gamma, right? But every time the force will be perpendicular to the surface. Do you think this is the correct pressure distribution for this one? And the direction? Okay, is it clear of how we are doing that and why we're doing that? Okay, so our purpose is, once we know the pressure distribution, obviously the next step is we need to calculate the very resultant force, which is Fr. Up to this point, are we clear how we are doing that, why we are doing that, and everything? Everyone? Okay. So once you are done with this part, let me know. I will go to the next slide. You're good, everyone? Okay, so I'm moving to next slide. If our calculation, okay, and I will draw this one again. I will draw this multiple times. That's because I'm just moving to different new slide. You can keep that one. You already do that. Okay. So that was the FR. That was 12 meter. To this point, that was 424 meters, right? Okay. Now the FR calculation, FR is what? Gamma H prime A, right? Now this A, should we consider this area or the area of the gate or both? Like which area I should consider for this A here? Only the gate or gate plus the vertical one? Everyone, do you think we should use only the gate area? Yes, that is correct, because we are only considering the force on the gate. So that should be the area. So I can write down area of gate. That will remove all the confusion. Now this one is the SI system. What will be the gamma of water? Okay, I'm hearing lots of different numbers.
I have no.
You have no clue? What? 9,810. Yes.
Go.
Okay.
See, I had the right number, just not the.
Oh, in that way, I can always say it's 198. Does that make any sense?
That's what I said.
That's why that didn't make any sense. It should be in the correct order. Okay, so we need to do the calculation of H prime. We will do that. Let's do the easier part, area of the gate. So area of the gate is what? If I draw the gate here,
60.60.
so 60 centimeter equals to 0.6 meter, right?
Yeah.
Okay, so the area will be 0.6. Okay. Now the main complex part where we need to calculate that H prime. Okay, so that's what we will calculate now. H prime will be, you tell me what will be the H prime? From the water surface, this will be the distance to the centroid of that surface, right? So midpoint of that surface, that is the H bar. How can I find H bar? 12 plus this one is 12 and this one will be what? Half of 0.424, yes. So I think for this problem, that was the difficult part, and some of you will struggle on that part. So let's make sure we understand that. We need to know the distance from water surface to centroid of the area, right? And since this is a rectangular area, here the centroid will be exactly at what? Midpoint. And this distance is 0.424 over 2. Right? And how did you get 0.424? 0.424 is actually 0.6 times 70. In case you forgot, that was the reason you got 424. Okay.
Wait, wouldn't it be sine 45?
Oh, yes, yes, you're correct. I'm using the 70 from Hoover Dam. You're correct. Yes. Okay. Now what is the H prime? 1, 2. meter, right? Okay, so you can use that one directly here, 12.212, and give me the answer with proper unit. So the unit should be Newton meter cube. Here it's meter, this one is meter square. So meter cube got cancelled out. You will have only the newtons, but give me the number. What will be the number?
43,120.
43,120. Anyone else got anything? Okay, 120, 127. I got 42, 130. So everything is pretty much same. So write down what number you got. As long as it is close to 43,100 something, it should be fine. Okay. Now we still need to find what?
Location.
Location. Yes. So that should be our next step. Are we done with this one? Let's start working on the location. If anyone is not done, please stop me when I change the slide. So yp equals to y bar ix bar y bar a. Now I will come back to the very first slide. Yp is actually what? From that water surface, the distance of that f is actually the yp, right? Okay, so let's calculate the y bar. I think we already know the area, which is 0.6 times 0.6. Do we know the y bar or ix bar or anything? We don't know that, but we know the relation between h and y. This one, right?
Yeah.
So the relation will be same for y bar also. Do we know the h bar? Do we know the h bar?
Yeah.
What is that? 12.212 sine 45. Calculate that. What is that? And then you will calculate ix also. I will draw a picture of gate. 1.6 meter. Okay, what y bar you got?
Seventeen point two seven.
17.27 from the water surface, right? Now, what will be the ix? What is the shape of the gate? Rectangular, trapezoidal, triangular, circular? What type of surface we are having here? The gate, 6 by 6, square, or in other way, you can actually consider that rectangular just for the equation purpose. So b h cube over 12. Give me that number also. 17.27. 17.27. Point 0.018 meter to the power 4. Okay, 0.018. Now, what is the final answer we got for yp? That should be very close to 17.27. Right? Because this number is very, very small. So it's kind of same number you are having, which is 17.27. It's like you work a lot, finally, you got nothing. Do you think you are done with this class example?
No.
No, because the question was what would be the force to open the gate? If we go back here, what would be the force? That's what you need to calculate. How can you find that? You have this force, you have distance. Force over area, you have two different force and you don't know anything about P. You don't know the relation between P and F. You need to check the moments about these points. And that's how you can get the value of P. So let's do that very quickly. We have 2 minutes. If you can do that, that will be great, so that all the solution for example 9 will be in one video. If we can't do that. Okay, so this one is, let's name this point as O. This one is point P. Do you know the distance of that? You know that actually, because that's on the edge of the gate, right?
Yes.
So I will use this one, FR. So this one is 0.6. Yes, good. And we know the distance of this one, 17.27. So what will be this distance? Can anyone tell me? What is the total distance here? What is the total distance here? It's kind of tricky. We need, I don't think I can complete that within today. Let's check that. I need to calculate that. Let's go back here. Yeah, we don't have time. So what I will do, or what we will do, not only I, will start from this point on Wednesday, okay? So Monday, you have a different topic, which is the buoyancy and the stability. You will watch that video, you will take the quiz, and then on Wednesday, we'll start working on this problem, okay? You all have a good weekend and a very happy parents' weekend. I'll see you on Wednesday.
No.